graphing, now people, if it's graphing and you have a calculator, yeah, you should be golden, but I don't know about it. Graphing, square root, joding, and cube root functions. Okay, so a very, very quick review of yesterday. Remember yesterday? What's this the graph of? Y is equal to x squared. Okay? What's his inverse? Okay, if x is equal to y squared, then what's y equal to? There you go, the square root of x. Okay? So that's his inverse. Now, what did it look like? A sideways parabola, right? That opens to the right. But we restricted it to what? Just which part? Yeah, the top part up here. Okay? So it looks like that. Now, alright, here's the questions that's gotten all over me today. Domain. No, that's a D and a colon. No. Domain. When I say domain, what are you supposed to think? Very good. Did you know that last period those kids couldn't tell me that? I said, domain, what are you supposed to think? And they go, X. And I go, no. That was first grade. Now we're in 10th grade. So, well, that was a long time ago. Okay? So, restrictions. How many restrictions did you have to learn? 2. You only had to learn 2. I didn't ask you to learn 10, did I? 2. What were they? If there is an x in the denominator, that creates a restriction because what number is not allowed in the denominator? Very good. You can't divide by 0. Okay? What's the other restriction? A radical. There's a radical. Not just a radical, but what has to be under the radical? An x under the radical. Okay? An x under the radical will create a restriction because what kind of numbers can you not have under the radical? Negative. Because those would be imaginary, and y'all, they're not showing up on this coordinate plane. Okay? We did graph imaginary numbers, so don't go, whoa, why? I thought we graphed those imaginary numbers. We did, but we graphed them on an axis that had a real axis, remember that? And an imaginary axis. We have an x-axis and a y-axis. Okay? So they wouldn't show up. So, do you remember if there were an x in the denominator, how did I tell you to figure out what your domain was? Very good, Bailey. You equal it to 0, and then you solve for x, and then you go, x cannot be -1. Because if I plug -1 in, he makes a 0 on the bottom, right? So my domain would be from -infinity to -1, exclusive, and then from -1 to positive infinity, right? Okay, don't have to write that down because we're not doing that right now. It'll come up a chapter or so later, all right? Well, what about the radical? How did we solve the radical? What did we do? What did we say about the x? What kind of numbers does that have to be? Positive, okay. Could it be 0? Can you take this? Oh, there you go. That's exactly what I wanted. X, you take what's under the radical and you say you must be greater than or equal to 0. I'm going to make that last period class go back and listen to this because you guys knew this stuff, okay? They acted like they had never heard that stuff before. So, x is greater than or equal to 0. What would that domain be in interval notation? No, that's set notation, guys. Interval notation. 0 what? Inclusive all the way to positive infinity. That's interval notation. Okay? That infinity? It's anything greater than or equal to 0.
I get that part, but if it's always going, and then it should be inclusive No, because
You can't include something that doesn't ever stop. Okay? It's like trying to talk to a kindergartner at recess, and they're just running around like crazy people. You can't talk to them. That's why I think it's a shame that little kids can't talk in the cafeteria. You can't talk in the hall. You can't talk in the restaurant. You can't talk on the bus. You can't talk. You can't talk at recess because, please, I have so much energy, I have to expend it. They're just running. If you've ever watched them, that's all they do. They hit the door and they just run. They run, run, run until someone blows the whistle and says, come back inside. So, when are they supposed to talk? They're kindergarten kids. Yeah, it's crazy. All right, so, let's do this. Let's just go ahead. I'm going to teach this one a little bit different than I taught the other classes. Okay? Let's just go ahead and go, hey, just, what's his range? I want to see how it works. What's his range?
0 to positive.
Very good. 0 to positive infinity. Range is the y. Be sure that when you do the range and domain, you do interval notation, that the smallest number comes first. Okay? Smallest number always has to come first. All right, so let's just talk about some of these graphs. I'm just going to draw me a big old graph. Okay? And we're going to be kind of specific about it. And we're going to take the equations and do all these weird things to the equations and see what that does to our graph. Now, notice that when I do this, I'm not going to pick up a calculator because once you know what the parent function looks like, then you should know what the transformations look like. So I'm going to go ahead and graph my parent function, y is equal to the square root of x. And I'm going to tell you that on the square root functions on your worksheet in the test, I'm going to expect 2 points. I want the starting point, and then I want one other point. Most of the time, it'll be most convenient to do the very next point. Okay? But I'll show you what I'm talking about. Where does this function start?
At 0.
At 0, 0, right? Why does it start at 0, 0? Because, guys, what is the square root of 0? People, why do I keep asking that and y'all keep going? Everybody's like you're not sure. Y'all, what's the square root of 0? Thank you. It's 0. So when x is 0, what's y? 0. That's where this function starts. Can it go to any of these x's to the left? No, you said, you just got finished telling me you can't take the square root of a negative number. Okay, that's imaginary. All right, so let's do the next number, 1. If x is 1, what's the square root of 1? So at 1, it's 1. Everybody okay with that? Do y'all want to do 2? Do y'all want to do 3?
No.
What about 4? Okay, what's the square root of 4? 2. So when x is 4, y is 2. Now what would be the next one that would be convenient to do?
9.
Like 9, the square root of 9 is 3. But, I mean, I think I got a good general idea of what my curve looks like. Okay? It looks just like this right here. Okay? Now, let's do this. Oh, tell me this. What's his domain?
Wait, domain. 0 inclusive infinity.
Very good. 0 inclusive to infinity. Guys, look, you can take what's underneath that radical and say you must be greater than or equal to 0, and that gives the domain. And look what my picture does. Does my picture not justify that domain? Where does that whole thing exist? To the right of the y-axis, where the x's are only from 0 to infinity. You see what I'm saying? Okay, so let's try another one. Y is equal to negative, no, let's don't do negative. Let's just do 3 times the square root of x. Okay? 3 times the square root of x. Now, people, that 3, is he an x? Is he with an x or a y? He's a y. How do you know he's not with the x? Yeah, he would have to be inside with that x to be an x. Okay, so he's a y. So is he making a vertical transformation or a horizontal transformation?
Horizontal. No, vertical.
Vertical, because that's what y's do, right? They run up and down. And Y's do just like we think they're going to do. So would that be a vertical stretch or a vertical shrink?
Vertical.
Stretch. No, this is just like those quadratics and those absolute value functions we did, right? This is a vertical stretch. Can you just picture what this card is going to look like if you vertically just stretched it up at the top?
It's going to go up.
Is it going to change this point right here?
No.
No. Is it going to change this point?
Yes.
Where is he going to be?
3 times higher.
3 times higher. Oh, my word. What's the square root of 1?
1.
What's 1 times 3?
3.
Oh, so instead of being 1, 1, he's 1, 3. All right? Let's go back to that 4 thing, okay? What's the square root of 4?
2.
What's 2 times 3?
6.
So at 4, it's at 6, right?
Mm-hmm.
Now, doesn't that, here it was at 0, 0. Doesn't that look exactly like what a vertical stretch should do to it? It just pulled it and stretched it up. Okay, very good. Let's try another one. Y is equal to oh, let's go back to that blue one for just a second. What's the domain of that thing? 0 inclusive to infinity. 0 inclusive to infinity. Okay, now let's look at the yellow one. All right? So, the yellow one, thank you, Spencer. Oh, that's what it said to you, Spencer. Yeah. Hang on just a second, it didn't turn on. Oh, wait. Okay, tap it twice. It has 4 beats. Perfect. Thank you. Okay, so, this was to infinity. All right. Now, look at this one, the yellow one. All right? What about this minus 2? Who's he with? X. How do X's? Where do X's move first? Where do they move? Left and right. How do they move? Opposite. So what's that minus 2 going to do? To the right 2. Okay? If you say plus 2, what's somebody going to do? They're going to go up 2. People don't say plus and minus 2. You say to the right, left, or up or down. Okay? So now I'm to the right 2. I'm right here. Okay? What's this plus 1? Is he an X or a Y? He's a Y. He's outside. Y's move where?
Up and down.
How?
The way you think.
The way you think. So where's that plus 1 going to do? Up 1. So now here is my beginning point. Okay? Now listen to me, guys. You can do this next part however you want to. I'm going to do it the easiest way. Okay? I'm going to do it the easiest and fastest way. If this is the beginning point, this next point is up 1 and over 1. Does everybody agree with that? Okay, so that's what I'm going to do. Do I have a vertical stretch or shrink or compression or anything? So, I'm just going to take this point and I'm going to go up 1 and over 1. Oh, wait, I'm sorry, I'm at the wrong point. I was like going, wait, what color am I? Up 1 and over 1. So here's my next point. Do I have a good idea now about what my graph's going to look like? I think I do. I think it's okay. Okay? It didn't have a stretch or anything. If it had a stretch, I might have wanted to find another point. Now look what you could have done. You could have said, well, this next point right here is 3. What's 3 minus 2? What's the square root of 1? What's 1 plus 1? Guess what? At 3, it's 2. You see what I'm saying? I mean, you can do it a lot of different ways, guys. Okay? But I think that's a good way. Now, look at that picture and tell me what his domain is. 2 inclusive all the way to infinity. Okay? Now, what if you didn't look at the picture, but you remembered what Miss Davis taught you? Oh, and she said, take what's under the radical, x minus 2, and say you must be what? Greater than or equal to 0. And then solve for x. Add 2 to both sides. X is greater than or equal to 2. Oh, that's just exactly what that says. Okay? So, you can do it this way, or you can go by looks. Be careful with those looks things, okay? All right, here's the next one. Are you ready? What? I changed colors. Uh-oh. Uh-oh, Spencer. That's a classic case of colorblind. It's okay. It's okay. They can put those things in your clothes, the granimal things, and it'll tell you what matches and what doesn't. Okay, so here we go. Let's look at this one right here, right? What's the first thing that you see that we need to think about? That negative. Now, is that negative on the X or the Y? So, would that be the first thing I needed to do or the last thing I needed to do? Very good. Think about those parabolas, guys. Think about those parabolas. When we go do this, what's the very first thing we say? That thing opens down. That's the first thing that we do, okay? That thing opens down. So whenever it's on the Y, it's the first thing you do. Now, let's think about that, because if X's are weird, and they're always weird, if I put it on the X, it's going to be the last thing. The last thing you do. If when I put it, now listen, let me make sure I say this right. If when I put it on the Y, it's the first thing that I do, then if I put it on the X, it has to be the last thing I do, okay? That's really, really important. You're not going to get it if you don't remember that, okay? Putting it on the X is the most difficult skill. All right, so he's on the Y. So now all I've done is take this little white guy right here and did what to him? Flipped him or reflected him over what? The X-axis, okay? If he's on the Y, he reflects him over the X-axis. So now instead of going like this, he's just going like this. He's that bottom half of that parabola, right? Okay, so he's going down like this. What is that plus 3 going to do to him? Left 3. 1, 2, 3. What's the minus 1 going to do to him? Down 1. So now there's my starting point. How do I find the next point? Down 1? Down 1 over 1. There is no vertical stretch or compression on that thing, so here is my graph. Now, I could, like, just put some other things. Like, 1 might be a good point to pick, right? Because 1 plus 3 is 4, and what's the square root of 4? 2. And what's the opposite of 2? And what's negative 2 minus 1? So at 1, it's negative 3. Oh, look how, I'm pretty good, aren't I? Okay? All right. So, everybody understand. What's my domain? Remember, do what? Yes, go. Perfect. Negative 3 inclusive to positive infinity. So I could found it by looking at my picture, okay? Or I could have found it by doing this, guys. X plus 3 is greater than or equal to 0. X is greater than or equal to negative 3. That's what that states. Okay, everybody okay? Anybody got a question? Okay. So let's do one now that's like one of the most difficult ones, okay? This one's going to be the hardest one. So, do what? They are kind of close. I'll agree they're kind of close. Yeah, this one's a little mustardy, and this one's, the greens are hard because they if you get them dark, they just don't show up very well. So, y is equal to, let's do this, 2 times the square root of negative x, let's go minus 2, and let's go plus 1. Let's take this one right here, and I put a 2 out front, which is going to be a what? A vertical stretch. So it's going to make him a little taller, okay? But then I threw that little negative in on that x. So let's see what happens to that. All right. So this 2 is going to be a vertical stretch. Do you agree? This negative, what's it going to do?
Is it going to open down?
Reflect it across the y-axis. Y'all think about it. It's just the opposite. If I put the negative on the y out here, and it reflects it across the x-axis, then if I put it on the x, it's going to reflect it across the y-axis. Now, when do I do that? Last. That's the very last thing I'll do. Okay, what does this minus 2 do to it? To the right 2. What does this plus 1 do to it? Okay, so let's do that first. Let's start from this beginning point, that 0, 0 point, and where do I want to go? To the right 2 and up 1, right? Everybody agree I'm right here? Now, normally I would do this point, and since the stretch is of 2, instead of going up 1 and over 1, I'll go where? Up 2 and over 1. That's a vertical stretch. Now look, notice what am I drawing that thing? I'm not, people. I'm just like picturing it. Okay? I made it dotted because that's what it would look like without that negative on that x. Is everybody with me? Everybody okay? Now, if I take this thing right here and I reflect it over the y-axis, where does this point at 2, 1 go? And now I can go up 2 and to the left 1. There's that second point. And this is what your parabola looks like. Now, why are these so difficult for kids? Because a kid is going to look at this right here, they're going to pop it in their calculator, and I'm going to say, what transformations took place? And they're going to say, that thing went where? To the left 2. Did it go to the left 2, people? It did not go to the left 2. It looks like it did, but that's because you reflected it over the y-axis. But don't look at that and say he went to the left. And another reason I don't like going by looks, know your properties. We don't change the way we do things in the middle of a game. The rule is, if it's with an x, it does the opposite of what you think it's going to do. So a minus 2 goes to the right 2. Okay? So I tried to draw you a picture of what really it would have looked like, but then with that negative, the effect that it had on it. Okay? So now be really careful and tell me, what is my domain?
From negative infinity to
Negative infinity to negative 2 inclusive. Now, could I have said negative 2 to negative infinity? No. Because remember that in interval notation, the smallest number has to be on the left. Okay? It has to be logical in our brains. That's the way we think. Okay, so watch this. You see this little piece right here under my radical? Negative x minus 2, greater than or equal to 0. Let's add 2 to both sides. Negative x is greater than or equal to what? 2. When you divide by negative 1, what do you have to remember to do? X is less than or equal to negative 2. Just what that says. Okay? Makes sense, right? Everybody got it? Okay, so can y'all do domains and ranges of these things? If I asked you about the ranges, what about the range of this pink one? What is the range of the pink one? Just look at the picture for the range. Perfect. 1 to infinity. Whenever I find ranges, I usually look at my picture. Okay? I know this number out here is going to affect my range, so I'm thinking that number, but I'm going to look at my picture. Which one's going to be the hardest one? The green one?
from negative infinity to 1.
That's exactly right. What is going to be the mistake?
1 to negative.
1 to negative infinity. You want to start at that point, but this one's going down. So guys, you have to actually, whenever I do the range, I look at my picture and I start at the bottom and I say, what's the smallest x can be? I mean, y. So negative infinity all the way up to negative 1. Remember, infinities are never included. Okay, so always put parentheses around them. Anybody got a question? Everybody okay? Here, what's this? Here's yellow. Well, I'm not finished yet. We can still got to do cube roots. Do they still look the same?
When I look, okay.
You want to pause your video?
Okay, when I look, okay. I'm trying to show you what I mean. So, whenever I look right there, like right down that line, they look different, but when I look at this one looks the same as that one.
Yep. Okay, so let's talk about the cubic and the cube root functions. Okay? Now y'all listen to me. Are the cubic and the cube root functions, are the rules for transformations going to be the same? Yeah, that's what's so cool about transformations, guys. Okay? That's what's so cool about it. I mean, you know how to do it. You just showed me that you did, so it's not going to be any different. All right. So y is equal to x to the third. That's a cubic function, and this is what it looks like. Okay? What is his domain? Thank you. Abby said, man, look at that thing. He has no restrictions. If he doesn't have any restrictions, what's his domain? Negative infinity to positive infinity. What's his range? Perfect. Y'all, guess what? If it's a cubic function, I don't care what kind of transformation you do on it, guess what his domain always is? Negative infinity to positive. Guess what his range always is? There you go. Okay, so now let's talk about his inverse function, which is the cube root of x. Okay? Now, this is what it looks like. Okay, so just a few things I want you to look at. Look at the blue. That's the x cubed. That's the cubic function. Do you see how he kind of snakes and hangs around the y-axis? What's this yellow guy doing? Yeah, he's snaking and hanging around the x-axis because you changed the x's and the y's. You switched them. Okay? Now, let's talk about his domain. Does he have any restrictions? Why? It has an x under a radical. Why does it? But it has an x under the radical. Why does it not have any? I mean, I'm looking at the picture and I'm going, the picture says it's from negative infinity. Because you can take, it's an odd root, because you can take a cube root of a negative or a positive. Because like Tommy said, what's the cube root of negative 8? Negative 2. It keeps the sign of the radicand. Okay? So, like Paige said, only odd index numbers will not have any restrictions. Okay? If I took the square root of x, would that have a restriction? We just did that for like 30 minutes. Okay? So that had a restriction. This one does not have a restriction. Why? It's an odd index number. It's an odd root. What about the fifth root? Would it have any restrictions? No. So what's his domain if he doesn't have any restrictions? Oh my word. What about his range?
So, will always, no matter.
Cube root and cubic will always be negative infinity to positive infinity. Okay? So, let's just try one of them. Do you want me to draw a new axis or you want me to put it on here? I'm going to draw a new one because I got that cubic on there, and that's not what I want to talk about. Okay, so you can do the same one. You're fine. Whatever you want to do. Okay, so but before I do want to talk about how many points. Does anybody remember how many points I told you had to have on these? 3. 3 points on these, 2 points on the others. Okay? Obviously, when I give you your worksheet in just a little while, it's going to have some graphing problems, right? They're going to ask you to graph them, tell me what the domain and the range is. Okay? So, here's what I'm going to graph the parent function. Y is equal to the cube root of x. Okay? Everybody knows what it looks like. Just like that little S thing. Okay? 0, 0, right? What's the cube root of 0? 0. Let's do 1. What's the cube root of 1? 1. Oh, that's not bad. Let's do negative 1. What's the cube root of negative 1? Negative 1. Remember, it keeps a sign. Okay? So, here is... Oh, he stopped drawing right in the middle. Come on, guy. You goober. Yay, Spencer. My hero. Very good. All right. So there's, oh no.
That was not me.
That was me. My pen got stuck on there. Oh, now it's stuck again, but it won't write or anything. Just scribble down the side, Spencer. Okay. That's good. Thank you.
That did not work at all.
All right. So let's do some things to this. I'm just going to do one. I think you'll all be okay, don't you? Y is equal to, let's go negative 2 times the cube root of x. What do you want to do? Plus or minus? Plus x plus 1, and then what do you want to do? Plus or minus? Minus 3. Is that okay?
Yes.
Okay. So what's the first thing I want to think about? That negative. What's that negative going to do to this white function? Reflect it. I keep saying that. Reflect it over what? The x-axis. So now, instead of going like this, he's doing like this. Does everybody see it? This part down here is up here, and this part up here is down there. Okay, so now he looks like this. And that 2 is going to make it have a, what's it called? A what stretch? You can't just say a stretch. A vertical stretch. And it is a vertical stretch of 2. Okay? It has a vertical stretch of 2. Which means that I'm going to take this middle point, and that's the point that I'm going to move all around. And then how am I going to get this one? I'm going to go where? Up 2 and over 1, and this one will be down 2 and left 1. Okay? All right. So here we go. What's the plus 1 do to it? Sorry. Now what does the minus 3 do to it? 1, 2, 3. So this is that middle center point. Okay? Now, how do I find the point to the left of this? You tell me.
You go down.
Up 2 and back 1. Very good, because it's reflected over that x-axis, so it's kind of backwards. And how do I find the point to the right of this? Down 2 and to the right 1. Okay? So here is my function. Okay, now I'm going to warn you, okay, because some of you are you're going to have these points on your, you're going to have these points on your, oh, I can't see. My brain's not working. Yes, thank you. Your graph, and you're going to want to do weird stuff like this. Does that curve look in any way like this curve? No. Okay? But I'm just warning you right now, this curve is a little awkward to draw. You've been used to drawing these and seeing these, so they tend to want to suck you in. You be careful, because I'm marking that wrong. Okay? I'll count all your points off for your graph. It's not right. This doesn't look anything like that. Okay? So, be careful when you're drawing these cube root functions. What is his domain? And what is his range? And so if you miss a domain and a range for a cubic function, what?
You're sad.
You're sad. You're sad. You're really going to be sad. Going to be sad.
So no matter what, it'll always be negative.
It's always, it doesn't matter what I do to it. That's what it always is. Okay, one last problem and then we're finished, okay? Here's the problem. Anybody know what this is? A wrecking ball. No.
I'll smack out a lollipop.
It starts with a P. Thank you. A pendulum. That's what a bunch of kids, that's what a bunch of the kids have said. What's a pendulum? Okay.
Upside down metronome.
It's like, have you ever seen a grandfather clock? The thing that swings at the bottom of a grandfather clock. That's a pendulum. Okay? Now,
They will unless.
listen, the period of the pendulum is how long it takes to swing back and forth one time. Okay? So what I'm talking about is how long it takes this pendulum to swing from here all the way over to here and all the way back again. That is called his period. How long? This, y'all, next year, you're going to talk about this kind of stuff a whole lot because the sine function and the cosine function in trig are all what we call cyclic functions. They follow a cycle, and they have a period. Lots of things in the world do that. The moon phases. What's their period? 28 days. 28 days, okay? Does, what else has a period around here? What about the tides?
Well, that's controlled by the moon.
Well, it is, but it's how often? Every what? 12 hours. Don't y'all know? Y'all grew up down here and y'all don't know that? The tides happen every 12 hours? Oh, wow. What? Y'all are on a different path. That's cyclic too. So we're not talking about that. But that is cyclic. Okay. And it does happen every so many days. Okay. People, I could tell by their eyes, they were like. Okay.
You're at that side of the room.
You don't know what a tide is?
I do.
Oh my God.
The tide is how the water comes in and then it goes out. High tide, low tide. Okay? Yes, it's 1.11.
Is that an L?
It is an L. Okay, so T is the time it takes to complete one period in seconds. Okay? T is the time it takes to complete one period in seconds. L, what's going to change that time? The length of what?
The length of the pendulum.
Yeah, the length of the pendulum. That is the length of the pendulum. And it's in feet. Okay? So here's what I want to know. How long does the pendulum have to be to have a period of 3 seconds? Now, people, you could plug that 3 in right there for that T, right, and solve this thing. Tell me what you would do. Divide by 1.11, and then what would you do? Square it. They square rooted it, so you would have to square both sides, and that would be your answer. I'm going to show you another way to do it, because this is a good thing to think about. Let's go to our calculators, all right? I'm going to put that formula.
I feel like someone's taking your
Do what?
No, they're all over there.
A lot of them are over there. I should be just missing 2. But don't be taking them, guys, because next week I think Mr. Ryan's going to take them like Tuesday or Wednesday. Ooh. No, he's not taking them.
I can't do the test without it.
Yeah, we can't do this test without a calculator. So I'll have to make sure we're okay on that, but I'll see. Okay. So, for the test, the STAR algebra test. Okay, so here we go. I went to y equals and I plugged in 1.11 times the square root of x. Here's the graph of it right here. People, does it look like it's supposed to look? It's a square root function, okay? It's a square root function. Now, I want to know what is the x when the y is 3, right?
Well, you put minus 3 at the end.
How about if I do this? What if I go over here to y equals, and I say, what about when y is 3, Mr. Calculator? What am I looking for? Very good. Isn't that easy? That's so easy. You just put y is 3. Tell me where y is 3. It's right here somewhere, so I'll go second and calculate. Number 5, the intersection. First curve, yes. Second curve, yes. Do you want to guess? No. What's my answer? 7.3 feet is how long the pendulum has to be in order for the time of his period to be 3. Okay? All right, so now I'm going to hand out your worksheets. Let's see, that's today and tomorrow. So we'll probably make them due Monday when you take your test. Okay?